All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is calculating molarity by dilution. Folks, you're going to need a calculator and a periodic table for this one, so if you don't have those handy, go ahead and pause the video and we'll get started. I think a good place to start with this particular worksheet is with a definition. I want to start by defining molarity. What do we mean by molarity? Well, molarity is really a quantitative way of expressing concentration. So, for example, let's just say that I had a beaker, just like this, and the beaker contains a certain amount of liquid water, right? So I'll put that much water into the beaker. And then I'm going to add some salt, all right? So these little dots represent salt crystals that have been dissolved into the water. So if we want to denote the molarity of this concentration of this solution, I'm going to need two pieces of information. I'm going to need to know the number of moles of solute, in this case is the salt, divided by the number of liters of water, pure water. If I know that, I'll divide one by the other. Moles per liter is molarity. So that's molarity. Now let's talk a little bit about dilution. What do we mean by dilution? Well, I think we all have an intuitive feel for this word. Dilution means to make the substance less concentrated. So let's just say that I have the solution that I'm talking about here, and I want to make it more dilute. How would I do that? Well, one thing that I could do is I could take the same container and I could simply add more liquid to the container. So instead of the salt being dissolved in this much water, maybe it was dissolved in that much water. So I've got the same amount of salt, but it's more, the particles are further apart in the solution. Same amount of salt, but further apart in the solution, and therefore more dilute. So by adding water, I went from more concentrated to more dilute. But how do we quantify that? Well, in order to do that, we're going to need a formula. And the formula we're going to use is this one right here. It's M1V1 is equal to M2V2. Now let's define each one of these variables. M1 is the concentration of the more concentrated solution, the one I've shown on the left. V1 is the volume of that concentrated solution. M2 is the concentration of the more dilute solution, and V2 is its volume. All right, so let's go through that one more time. M1, concentration of the more concentrated solution. V1 is its volume. M2 is the concentration of the more dilute solution that we're creating. And V2, of course, is its volume. So let's take a look at some problems. Number one says concentrated HCl, or hydrochloric acid, is 11.7 molar. What is the concentration of a solution made by diluting 25 milliliters to 1,000 milliliters? So this is going to be quite dilute because we're adding a lot of water. In fact, we're adding, what, 975 milliliters of water. We're going from 25 to 1,000 milliliters of water. So we can expect it to be quite dilute compared to the 11.7. Let's see how much we dilute it. We have M1V1 is equal to M2V2. So we're looking for M2. We're looking for the molarity of the more dilute solution, right? The more dilute solution. Remember, 2 is for dilute, 1 is for concentrated. So the molarity of the more dilute solution is equal to, so let's simply plug in. We have 11.7 molar times its volume, 250 milliliters. No need to convert that to liters as long as we keep both concentrated and dilute in milliliters, divided by 1,000 milliliters, right? Divided by 1,000 milliliters. So that gives us the M2 of 0.293. That's to the correct number of significant digits. Molar hydrochloric acid. That is the molarity then of the more dilute solution, and that will do it for number one. That's number one. Let's look at number two. Number two says, what volume of 15.6 molar ammonium hydroxide is needed to make 500 milliliters of a 3 molar solution? We'll go right back to the same formula. M1V1 is equal to M2V2. We're looking for the volume of the more concentrated solution, so we'll just plug in. M2, 3.00 molar, times V2, 500 milliliters, divided by 15.6 molar. When we do that calculation, V1, we get 96.2 milliliters. The fact that it's in milliliters is just fine. We're done with number two. Let's look at number 3. Number 3 says, what volume of 0.085 molar sulfuric acid can be prepared from 15 milliliters of a 35.9 molar sulfuric acid solution? So here we go. M1V1 is equal to M2V2. We're looking for V2. We're looking for the volume of the more dilute solution. So we'll just start plugging in. We have 35.9 molar times 15.0 milliliters. Leave it in the milliliters for now. That's just fine. We'll change it later. Divided by 0.085 molar. And when we do that calculation, we get 6.3 liters. That's the volume of the more dilute solution. But we're going to need it in milliliters, so we're going to multiply that by 1,000. We get 6,300 milliliters, right? 6,300 milliliters is our answer to number 3. Let's look at number 4. Number 4 says a solution was prepared by diluting 50 milliliters to 250 milliliters of a 0.477 molar potassium hydroxide solution. What was the concentration of the original solution? So we're looking for M1. So we say M1V1 is equal to M2V2. Let's manipulate that to get M1 by itself. When we do that, we get the following. Let's plug in 0.477 molar times 250 milliliters divided by 50 milliliters. When we do that calculation, we get this number. To the correct number of significant digits, 2.39 molar potassium hydroxide. And that'll do it for number 4. Let's look at number 5. Number 5 says 2.0 liters of acetic acid is made by diluting 75 milliliters of 17.6 molar acetic acid. What was the molarity, or what is the molarity of the new solution? So we have M1V1 is equal to M2V2. It's just a matter of plugging things in, but let's convert the milliliters to liters because remember molarity is moles per liter, not moles per milliliter. To get to liters, we're going to just divide by 1,000. We have 75 divided by 1,000 is 0.075 liters. Let's plug in. We're looking for M2. We're looking for the molarity of the new, more dilute solution. So M2 is equal to 0.075 liters times 17.6 molar. We'll divide that then by 2.0 liters. And that's going to give us M2 for the more dilute solution of 0.66 molar acetic acid. And that'll do it for number 5. Let's look at number 6, the last one. What volume of a 6.5 molar hydrochloric acid solution is needed to make 500 milliliters of a more dilute 3 molar hydrochloric acid solution? Let's once again use our formula. M1V1 is equal to M2V2. We're looking for the volume of the more concentrated solution, or V1. So V1 is equal to 500 milliliters times 3.00 molar, and we'll divide that by 6.58 molar. That's M1. And when we do that, we get this number, 228 milliliters. We'll leave it in milliliters. We're done with number 6, and we are done with this worksheet. You have a good evening, and we will see you on the next worksheet. Thank you. Bye-bye.